Chapter 3. Information Systems and its Components. Data, raw and unorganized piece of information without context. It is not meaningful and does not convey any message as such. It may be a qualitative, weight, height, color, or be quantitative, numbers, information, processed form of data which conveys some meaning. Data context equals info. Data is organized by organization from internal and external sources. System, group of interrelated and interdependent components working together to achieve a common goal. E.g., traffic light, human body, information system, computer-based IS, CBIS. It is the combination of hardware, software, people, data resources and network which processes data into information for specific purpose, objective. Examples: Tally, accounting software in India; QuickBooks, accounting software across world. Objectives: to convert the data into information which is useful and meaningful. It helps enterprises in a. Making decision. B. Controls the operation. C. Analyzing problems and creating new products or services as an output. Characteristics: A CBIS is developed on the basis of predetermined objective. B. Interrelated and interdependent subsystem. C. If one subsystem fails, whole system won't work. D. Components interact among themselves. E. Work done by individual subsystem is integrated to achieve common goal. Information System Model. IS model provides a framework that emphasizes four major concepts that can be applied to all types of information systems. A. Input. Data is collected from an organization or from external environments and converted into suitable format required for processing. B. Processing. A process is a series of steps undertaken to achieve desired outcome or goal. It facilitates conversion of data into information. C. Output. The system processes the data by applying the appropriate procedure on it and the information thus produced. Output is stored for future use or communicated to user. D. Storage. Storage of data shall be done at the most detailed level possible. Regular backups should be stored in a geographically different locations to avoid impact on both the original data and the backup data storage due to any major disasters such as flooding or fires, etc. E. Feedback. IS needs feedback that is returned to appropriate members of the enterprises to help them to evaluate at the input stage. Components of information system: people, resources, anyone who manage, run, program or use. IS black small square programmers, black small square system admin, black small square data entry operator, black small square help desk, black small square CEO and CIO. Computer system comprise of hardware, tangible portion of computer system that can be seen and touched. Black small square input devices, device through which user interacts with system, i.e. instructions are given to information system. Types: A. Text-based input keyboard. B. Point-based input mouse, light pens. C. Image-based scanner, barcode, QR code reader, MICR reader. D. Audio-based microphone. Black small square processing devices, process data using program instructions, perform calculations, and control other hardware devices. Examples: central processing unit, CPU, motherboard, network card, sound card, etc. most common processing device is CPU, which is the actual hardware that interprets and executes the software instructions, built on a small flake of silicon containing the equivalent of several million transistors, switches, which could be on or off, i.e. taking a value of 1 or 0. CPU is known as brain of computer and consists of following three functional units. A control unit, it controls flow of data and instruction to and from memory, interprets the instruction, and controls which tasks to execute and when. B. Arithmetic and logic unit performs arithmetic operations such as addition, subtraction, multiplication, and logical comparison of numbers, equal to, greater than, less than, etc. C. Processor registers. Registers are part of the computer processor which is used to hold a computer instruction, perform mathematical operation and execute commands. These are high-speed, very small memory units within CPU for storing small amount of data, mostly 32 or 64 bits. Registers could be accumulators, for keeping running totals of arithmetic values. B. Address registers, for storing memory addresses of instructions. C. Storage registers, for storing the data temporarily. And D. Miscellaneous, used for several functions for general purpose. Black small square data storage devices, memory where data and program is stored on temporary or permanent basis. Refers to the memory where data and programs are stored on temporary or permanent basis. Types are primary memory, also known as main memory or internal memory. It is directly accessed by the processor using data bus. Mainly of two types: random access memory, RAM, data retention. Volatile in nature means information is lost as soon as power is turned off. Persistence. The purpose is to hold program and data while they are in use. Temporary memory, information access. Info can be read as well as modified. Impact. High impact on systems performance. Costly per unit size. Speed quite high. Capacity. RAM memory is large and high capacity. Read-only memory, ROM, non-volatile in nature, contents remain intact even in absence of power. These are used to store small amount of information that is rarely changed during the life of the system. For quick reference by CPU. For example, BIOS, permanent memory. Info can be read only and not modified. No impact on system's performance. Cheap per unit size. Slower than RAM. ROM is generally small and of low capacity. Other cache memory helps to bridge the huge speed gap. B. W registers and primary memory. It is smaller, very fast memory inbuilt into CPU. Acts as a buffer between RAM and CPU. It stores data, frequently used by main memory so that registers, CPU can access it faster. E.g. values that have been computed earlier. B. Secondary memory. It is external memory, not directly accessible by CPU, but can be accessed by primary memory. Characteristics are non-volatile, permanent storage. B. Large capacity. C. Slower speed. D. Economical. Examples: hard disk, pen drive, memory card, etc. Processor registers vs. cache memory. Processor registers. These are high-speed memory units within CPU for storing small amount of data, mostly 32 or 64 bits. The registers are the only memory units most processors can operate on directly. Cache memory. It is fast memory built into a computer's CPU and is used to reduce the average time to access data from the main memory, an interface between CPU and main storage. It is not directly accessible for operations. Primary memory vs secondary memory. Primary, main memory, basic, directly accessible by processor, CPU. Data instructions or data to be currently executed are copied to main memory. Volatility, usually volatile. Formation made of semiconductors. Access speed. Accessing data from PM is faster. Size, smaller size. Expense, costlier than secondary memory. Memory, internal memory. Secondary memory, not directly accessible by CPU. Data to be permanently stored is kept in secondary memory. Non-volatile, made of magnetic and optical material. Accessing data from SM is slower. Larger size, cheaper than primary memory. External memory. Note: virtual memory is not a separate device but an imaginary memory. Supported by OS. If RAM required to run a program falls short, OS moves data from RAM to a space in HDD called paging file. This frees RAM to execute the work, thus, it is allocation of HD space to help RAM. Output devices. Device through which system response provides output to decision makers to solve problem. Examples: speakers, headphones, screen, monitor, printer, video, CBIS. Provide output to decision makers at all levels in an enterprise to solve business problems. The desired output may be in visual, audio or digital forms. Information shown on a display device is called soft copy because the information exists electronically and is displayed for a temporary period. Types of output: A. Textual output comprises of characters that are used to create words, sentences, and paragraphs. B. Graphical outputs are digital representations of non-text information, such as drawings, charts, photographs, and animation. C. Tactile output such as raised line. Drawings may be useful for some individuals who are blind. D. Audio output, any music, speech, or any other sound. E. Video output consists of images played back at speeds to provide the appearance of full motion. Software. Set of instructions and programs that tells computers what to do. Created through a process of coding, programming through language like C, Java, types OOSS, W. Set of instructions, programs, software that manages H, W resources and acts an intermediary. B, W hardware and app software. Examples: O personal computer, Windows, OS X, Linux, O mobile, tablet, Android, iOS, Tizen, Harmony OS, etc. Activities by OS, human FT. A. Performing hardware function acts as intermediary. B, WH, W and app S, W. B. User interface helps to connect user with IS. It may be GUI based, uses icons and menus, or QUI based. C. Memory management. Maximizes available memory and storage. Provides virtual memory, later. D. Logical access security. OS helps in user identification and authorization through password PIN. E. Networking capability. Helps to connect various hardwares. F. File management. Keeps a track of where each file is stored based on which it provides the file retrieval. G. Task management. Facilitates a user to work with more than one app at a time, i.e. multitasking. allows more than one user to use the system, i.e. time sharing. H. Hardware independence. Any device irrespective of manufacturer or design can use OS to run itself. OS provides application program interface, APIs, used to create app without considering details of H, W. OAP S, W. Include all software that causes computer to perform useful tasks other than running the computer itself. It addresses real-life problems of its end users, which may be business or scientific or any other problem. Application programs usually require an operating system to function. Examples: OAP Suite, MS Office, G Suite, O Content Access S, W, VLC, Abode PDF Reader, O Enterprise S, W, ERP like SAP. Advantages: A. Addresses user needs. B. Low threat from virus. C. Regular updates. Disadvantages: A. Costly development of app S, WB. Risk of virus attack. Data resources. Organization generates and collects huge quantity of different type of data like production-related data, HR-related data, market-related data, etc. These are stored in databases. Black small square data. Black small square database. Set of logically interrelated organized data, i.e., data of some context to manage unrelated data. Separate database is used. They store both O operational data produced from day-to-day working, as well as O non-operational data used for education, research, etc. Hierarchy of database. A. Database. Collection of files. B. File, table, entity. Collection of records. C. Record. Collection of fields. D. Field. Collection of characters. E. Characters. Collection of bits. Black small square database management system. Software that helps organization in organizing, controlling and using the data needed by apps. Helps to create and maintain well organized database. Normally single user operations that it can perform. O. Adding, deleting, or modifying files in database, and O. retrieving or querying data from existing files. Examples: A. Commercial DBMS, MySQL, Oracle. B. Personal DBMS, MS Access, OpenOffice. Black small square database. Models. Logical structure of a database and fundamentally determines in which manner data can be stored, organized and manipulated. Types. A. Hierarchical database model. Records, nodes are logically organized into a hierarchy of relationships in an inverted tree pattern. Top parent record that own other records is called parent record. Root record, which may have one or more child records, but no child record has more than one parent record. Each node is related to the others in a parent-child relationship. The hierarchical data structure implements one-to-one and one-to-many relationships. B. Network database model. This structure views all records in sets, wherein each set is composed of an owner record and one or more member records. It implements one-to-one, one-to-many, many-to-one and the many-to-many relationship types. It can represent the data more efficiently than in the hierarchical model. C. Relational database model. This allows collection of records in a tabular structure. Main terms used in this model are a relation, defined as a table with columns and rows. B. Named columns of the table as attributes, fields, and C. Domains as set of values the attributes can take. The ordering of columns is immaterial in a Table. There cannot be identical record in a table. Each record will contain a single value for each of its attributes. RDB contains multiple tables, with all the tables connected by one or more common fields. For each table, one of the fields is identified as a primary key, which is the unique identifier for each record in the table. If the primary key of one table is used in another table to access the former, it is called foreign key. Popular examples of RDB are Microsoft Access, MySQL, and Oracle. The object-oriented database model. It is based on the concept that the world can be modeled in terms of objects and their interactions. This provides a mechanism to store complex data such as images, audio and video, etc. In this, the data is modeled and created as objects. DBMS helps programmers make objects which are an independently functioning application or program, assigned with a specific task or role to perform. Advantages of DBMS: 1. Permitting data sharing. Same info is available to different users. 2. Minimize data redundancy, as duplication of info is either eliminated or controlled or reduced. It significantly reduces cost of storing information on storage devices. 3. Integrity can be maintained. Database contains accurate, consistent and up-to-date data. Change in database is allowed to be made only by authorized person. 4. Program and file consistency, as file formats and programs are standardized. 5. User-friendly. Enable user to access data and use it easily without need of computer expert. 6. Improved security. Since multiple users use same data, necessary to define user access rules on need-to-know and need-to-do basis. 7. Program, data independence. Data resides in DB and not in app, so both are independent. 8. Faster application development. Since data is already present in DB, so app developer has to think only about logic to retrieve data in the way a user needs. Disadvantages of DBMS: 1. Costly and time-consuming, in terms of both system and user training. 2. Security risk. It may be possible for some unauthorized user to access the DB. In such cases, it could be at all or nothing proposition. Network and communication system: black small square. Computer network. Collection of computers and other hardware interconnected by communication. Channel, mode, medium which allows sharing of data, resources and information. Black small square. Telecommunication. Sharing, exchanging of data, info over computer network. It helps in increase in efficiency of operations, improvement in effectiveness of management, and innovation in market. Place network and communication system. Consists of both hardware as well as software. Links. Various pieces of hardware and transfer data from one physical location to another. Computers and communications equipment can be connected in networks for sharing voice, data, images, sound and video. Types. Connection-oriented (NW). First connection is established between sender and receiver. Then data is exchanged, e.g. telephone. Transfer of movie from laptop. Connection less (NW). No prior connection is made before data exchange. Inspired by portal network, e.g. email. SMS computer network is modeled to address following basic issues. 1. Routing. Process of deciding on how to communicate the data from source to destination in ANW. 2. Bandwidth amount of data, which can be transferred across the network in a given time. Higher bandwidth, higher is the speed of data transfer and faster the website loads. 3. Resilience, ability of a network to recover from any kind of error like power failure, connection failure, etc. If one server is down, other will manage. 4. Contention. Situation where there is some conflict for some common resource in a network, e.g. two or more computer systems try to communicate at the same time. Policy should be made for priority access. Benefits of computer network. A. Computational power is distributed among computers in network. This reduces load on individual system and improve performance. B. User communication. It allows users to communicate using email, video conferencing, etc. C. Resource sharing. Data stored in database can be shared across different systems using computer network. Similarly, H. W-like printer can be shared. D. Reliability. Enable critical operations to run across different systems 24/7 which are distributed across network. Hence reliability increases. E. Distributed nature of information enables distribution of info geographically as well as consolidation of info when required, e.g. preparing FS of bank. Value and impact of telecommunication. A. Time compression enables organization to transmit data and information quickly and accurately. B. W. Remote sites. B. Overcoming geographical dispersion enables org with units in remote areas to function as I unit. C. Restructuring of business relationship eliminates intermediaries from various business processes. This results in increased operational efficiency. Information system controls black small square objectives of IS controls a undesired risk. Events are prevented, detected, created. B. To ensure business objectives are achieved. Black small square how above. Objectives are achieved by designing and implementing effective information control framework, which comprises policies, procedures, practices, and organization structure that gives reasonable assurance that business objectives shall be achieved. Black small square critical controls lacking in a computerized environment are as follows: a lack of management understanding of its risks and related controls. B. Lack of awareness and knowledge of its risks and controls amongst the business users and even IT staff. C. Absence or inadequate is control framework. D. Complexity of implementation of controls. Types of IS controls. Objective of controls. 1. Preventive control. It prevents errors, omissions or security incidents from happening. Proactive in nature. Can be implemented in manual or computerized environment. Characteristics. A clear-cut understanding about the vulnerabilities of the asset. B. Understanding probable threats. C. Provision of necessary controls to prevent probable threats from materializing. Examples: black small square locks, security guards, black small square fireproof walls, smoke detectors, black small square qualified personnel, black small square training and documentation, black small square PIN and password, black small square intrusion prevention system, black small square firewall and antivirus. 2. Detective control. Designed to detect errors, omissions or security incidents that escape preventive controls. Investigative in nature. Characteristics. A clear understanding of lawful activities. B. Established mechanism to refer the reported security incident to appropriate person. C. Interaction with preventive control to prevent such act from occurring in future. D. Surprise checks by supervisor. Examples: black small square fire alarm, CCTV camera, black small square cash counting, black small square review of payroll reports, black small square monitor actual expenditures against budget, black small square duplicate checking of calculations, black small square internal audit functions, black small square bank reconciliation, black small square intrusion detection. System 3. Corrective control. Designed to correct errors, omissions or security incidents once they have been detected. Reactive in nature. Reduces impact of risk, security incident once it has been detected. Characteristics. A. Minimizing impact of threat. B. Identifying root cause of problem. C. Provide remedy. D. Getting feedback. E. Modifying preventive controls to prevent future occurrence. Corrective process should also be subject to preventive and detective controls. It's more effective to prevent error or detect them as early as possible to their source. Examples: black small square quarantining the virus, black small square system reboot, black small square rerun procedure, black small square corrective journal entries, black small square business continuity plan and backup procedure. Nature of IS resources. 1. Environmental control. Related to IT environment in which IS functions. Environmental exposures and relevant controls are as follows. 1.1. Fire exposure. Damage to equipment and facility due to fire. Controls. A. Install smoke detectors. B. Install manual and automatic fire alarms at strategic location. C. Install fire extinguishers. D. Norms to reduce electric firing. I.e., computer room shouldn't be on basement or ground floor, and fire-resistant material should be used with less wood and plastic. E. Regular inspection by fire department officials and procedures to be followed during an emergency should be properly documented. Fire exits should be clearly marked. F. Documented and tested emergency evacuation plans should emphasize human safety but should not leave information processing facilities physically unsecured. 1.2. Water exposure. Damage to equipment and facility due to water-related incidents like pipe burst, cyclone, floods, etc. Controls. A. Water detectors should be placed under the raised floor, near drain holes and near any unattended equipment storage facilities. B. Strategically locating the computer room should not be located in the basement of ground floor of a multi-story building. C. Install water alarms at strategic locations. D. Use of waterproof walls, ceilings and floors. E. Proper drainage. System 1.3. Electrical exposures. Due to electrical faults like sudden upsurge in power supply, voltage fluctuations, non-availability of electricity, etc. Controls. A. Electrical surge protectors built into UPS. B. Uninterruptible power system, generator. C. Voltage regulator and circuit breakers. D. Emergency power off switch. 1.4. Pollution damage. Major pollutant is dust which can cause permanent damage to H, W and stored data. Controls. A. Regular cleaning. B. Prohibition on eating, drinking and smoking in IS facility. C. Power leads from 2 substation. 2. Physical access control. Physical security of tangible and intangible IS resources. It is applied against physical exposures which include abuse of information processing device, theft, damage, blackmail, etc. 2.1. Locks on doors. A. Bolting door lock. No duplicate key. B. Cipher locks. Combination locks. To enter, a person presses a 4-digit number, and the door will unlock for a predetermined period. C. Electronic door locks. Magnetic or chip-based plastics card key is used to gain access in these systems. 2.2. Physical identification medium. A. Personal identification number, PIN, means to identify and verify authenticity of user. User needs to log in by inserting a card in some device and then enter their PIN via a PIN keypad for authentication. B. Plastic card, used for identification purposes. C. Identification badge, can be issued to personnel as well as visitors. 2.3. Logging on facility official record of access, activities. A. Manual logging. Visitors sign visitors log indicating their name, date and time of visit. Company represented, purpose of visit, and person to see. B. Electronic logging, combination of biometric security and electronic security system. Maintains details, logs of access attempt, whether failed or successful. 2.4. Other packs are CCTV monitored by security. B. Simple security guard. C. Controlled visitor access. Responsible employee will escort visitor. D. Single entry. Point E. Dead man's door. Pair of doors where first entry door must close and lock, for second door to open, with only one person permitted in the holding area. F. Alarm system and perimeter fencing. 3. Logical access control. Black small square LAC is applied to protect IS from logical access violators like hacker, current and past employees, is personnel, end user, etc. Black small square ensures that logical access to system, data, program, OS is restricted to authorized users only. Black small square key factors considered in designing logical access controls include O confidentiality and privacy requirements, O authorization, authentication and incident handling, O virus prevention and detection, O firewalls, centralized security administration, user training and tools for monitoring compliance. 3.1. User access management involves administration within a system for giving individual users the access to the tools they require at the right time. A. User reg info. W. R. T. User is documented. Deregistration is equally imp. B. Privilege management. User access and privileges should be aligned with his duties, i.e., need to know basis or need to do basis. C. User password. MGT involves activities like creation, storage, revocation and reissue of password. D. Review of user access rights over a period of time as duties and responsibilities change. 3.2. User responsibility. A. Password use should be strong, min length, special character, and should be changed periodically. B. Unattended user equipment. User should be educated not to leave their device unattended and unprotected. 3.3. Network access control. Internet connection exposes organization to harmful elements. A. Policy on use of N, W, selection of appropriate services and approval to access them should be part of this policy. B. Enforced path. User is routed through a Definite path for connecting to org. Network that may be through firewall. C. Firewall. System that enforces access control between two networks. D. Encryption. Discussed later. E. Segregation of networks sensitive. N. W. Like VPN between BO and HO is segregated from other Internet users. F. Callback devices aims to keep intruder off the intranet. It ensures access to N. W is allowed only from authorized telephone no or terminal. User is required to enter a password and then the system breaks the connection. If caller is authorized, the callback device dials the caller's no to establish a new connection. 3.4. OS access control. A. Automated terminal identification ensures that only authorized terminal is connected to ISB. Terminal login procedure. User provides ID and password to login system. First line of defense. C. Access token. After successful login by user, OS generates access token which contains user info. This info is used to provide access to user during the session. D. Access control list. OS has ACL which contains info on user's access rights. E. Terminal timeout. Log out the user if system is inactive for specified period. F. Limitation of connection time. Define available time slot for connection to OS. G. Duress. Alarm. Means to alert authorities if user is forced to execute a command. H. Password MGT. Could enforce selection of good passwords. 3.5. App and monitoring system access control. A. Information access restriction. Access to info is restricted by app. User can access only those data which is authorized. B. Sensitive system isolation, based on critical constitution of system. In org, it may be necessary to run specific system in isolation, e.g. cache counting. C. Event logging. All events should be logged, user ID, time of access, terminal location etc., archived and reviewed. D. Monitor system use. Based on risk assessment and criticality of system, it should be monitored. Extent of detail and frequency of review depends on sensitivity of system. E. Clock synchronization. Event logs maintained across the network must be synchronized for generating correct reports. Note: controls when mobile. Ease of access on the move provides efficiency and results in additional responsibility on the management to maintain information security. Theft of data carried on the disk drives of portable computers is a high risk factor. Both physical and logical access to these systems is critical. Information is to be encrypted and access identifications like fingerprint, iris, and smart cards are necessary security features. IS functions. Auditors have found two ways to be useful when conducting information systems audits, as given below. 1. Management control framework objective. It ensures that IS is developed, implemented, operated and maintained in planned and controlled manner. Types are top management controls. Should ensure that IS functions properly and meets strategic business objectives. Scope of controls includes framing high level of IT policies, procedures and standards. Controls flow from the top of an organization to down, but responsibility still lies with the senior management. 4 major functions of senior management. O. Planning. Top MGT prepares plan for achieving IS goals. 2 types of plans: Strategic and operational plan. Steering committee shall assume overall responsibility for IS function. Organizing includes creating IT organizational structure with documented roles and responsibilities and agreed job descriptions. Includes arranging and allocating resources needed to achieve goals determined in planning phase. and EO leading includes motivating and communicating with personnel. Ensures that personal objectives are aligned with org objectives so that there is harmony of objects with O. Conflict. Controlling includes comparing actual performance with planned performance. In case of any deviation, corrective action is taken. B. System development management controls related to controlling the process involved in system development lifecycle. Ensures proper documentation and authorization are available for each phase of system development. 6 steps. I. Problem definition and feasibility assessment. IS is developed to help resolve problems or to take advantage of opportunities. All the stakeholders must agree on the problem and feasibility. Assessment is done to obtain a commitment to change and to evaluate cost effectiveness of solutions. All solutions must be properly and formally authorized to ensure their economic justification and feasibility. E. Analysis of existing system. Designers need to analyze the existing system that involves 2 major tasks. A. Studying existing organizational history, structure, and culture to gain an understanding of social systems, and the willingness of stakeholders to change. B. Studying the existing product and information flows as the proposed system will be based primarily on current product and information flows. The designers need to understand strengths and weaknesses of existing products to determine the new system requirements and the extent of change required. E. Information processing system design. This phase involves following activities. A. Elicitation of detailed requirements. Either ask the stakeholders for their requirement if they are aware about it, or discover it through analysis and experimentation in case they are uncertain about their need. B. Design of data, information flow. Designers shall determine the flow of data, information, its frequency and timing, and the extent to which data and information flows will be formalized. Tools such as DFD can be used for this. C. Design of database and user interface involves determining its scope and structure, whereas the design of user interface determines the ways in which users interact with a system. D. Physical design involves breaking up the logical design into units which in turn can be decomposed further into implementation units such as programs and modules. E. Design of the hardware, software platform. In case the hardware and software platforms are not available in the organization, the new platforms are required to be designed to support the proposed system. IV. Hardware, software acquisition and procedures development. To purchase the new application system or hardware, a request for a proposal must be prepared, vendor proposals are sought, and final decision is made based on evaluation. V. Acceptance testing and conversion. Acceptance testing is carried out to identify errors or deficiencies in the system prior to its final release into production use. Conversion phase comprises the activities undertaken to place the new system in operation. VI. Operation and maintenance. The new system is run as a production system and periodically modified to better meet its objectives. The maintenance activities associated with these systems need to be approved and monitored carefully. C. Programming management controls black small square major phase in system development life cycle. Black small square objective. To produce or acquire and to implement high-quality programs, that is ICAI. Black small square. 6 phases of program development lifecycle and related controls are as below. Phases. Controls I. Planning involves estimating the resources required for software development, acquisition, and implementation. E. Design systematic approach to program design, like structured design approach or object-oriented design is adopted that will meet the requirements articulated. Design should be modular. E. Coding structured systematic approach is adopted for coding program with module implementation and integration strategy and proper documentation strategy. IV. Testing. Program is tested before implementation. 3 types. A. Unit test, right pointing arrow testing of individual program module. B. Integration test, right pointing arrow testing of group of program module. C. Whole of program testing, right pointing arrow focuses on whole program. V. Operation and management involves monitoring and making changes in system when required on timely basis. 3 types. A. Repair, corrective, right pointing arrow remove errors from S, W or fix the bugs. B. Perfective, right pointing arrow program is fine-tuned to reduce resource consumption, e.g. better UIC. Adaptive, right pointing arrow change in S, W due to change in user requirement. VI. Control runs parallel in all phases. 2 major purposes. A. Task progress in various software life cycle phases should be monitored against plan, and corrective action should be taken in case of any deviations. B. Control on overall S, W development, acquisition process to ensure it is accurate, authentic and complete. Techniques like work breakdown structures, WBS, Gantt charts and PERT, program evaluation and review technique, charts can be used to monitor progress against plan. D. Data resource management controls. Data is a critical resource. Centralized planning and controls are implemented for proper management. Data integrity is defined as maintenance, assurance, accuracy, consistency of data, and the control activities that are involved in maintaining it are as under. I. Definition controls. These controls are placed to ensure that the database always corresponds and comply with its definition standards. E. Existence. Backup controls. These controls ensure the existence of the database by establishing backup and recovery procedures. Backup refers to making copies of the data so that these additional copies may be used to restore the original data and ensure availability of system after a data loss due to unauthorized access, equipment failure or physical disaster. Various backup strategies like dual recording of data, periodic dumping of data, logging input transactions and changes to the data may be used. E. Access controls. These controls are designed to prevent unauthorized individual from viewing, retrieving, computing, or destroying the entity's data. User access controls are established through passwords, biometric controls, and data encryption controls. IV. Update controls. These controls restrict update of the database to authorized users in 2 ways, either by permitting only addition of data to the database or allowing users to change or delete existing data. V. Concurrency controls. These controls provide solutions, agreed upon schedules, and Strategies to overcome the data integrity problems that may arise when two update processes access the same data item at the same time. VI. Quality controls. These controls ensure the ICAI of data maintained in the database. The above is accomplished by a. Appointing senior trustworthy persons. B. Segregating duties to the extent possible. C. Maintaining and monitoring logs of data administrator and data administrator's activities. E. Quality assurance management controls, concerned with ensuring that a IS produced achieve certain quality goals. B. Development, implementation and maintenance is done as per quality standard. Who will ensure quality assurance? QA personnel who ensure the quality goals are established and clearly understood by all stakeholders. B. Compliance occurs with standard. C. Best practices in the industry are also incorporated during the production of information systems. F. Security management controls related to control based on nature of IS resources, i.e., it covers a environmental control, e.g. fire, water. B. Physical access control. C. Logical access control. Despite all controls. Disasters, i.e., events which critically hit the business continuity in irreversible manner may occur. Controls for disasters. 1. Disaster recovery plan deals with how the organization recovers from a disaster and comes back to its normalcy. A comprehensive DRP comprise 4 parts. An emergency plan. Actions to be undertaken immediately when a disaster occurs. A backup plan. Specifies the type of backup to be kept, frequency of taking backup, the procedures for making backup, etc. A recovery plan, to restore full IS capabilities, and a test plan, to identify deficiencies in the test plan. Business continuity plan, BCP, as compared to a DRP, mainly deals with carrying on the critical business operations in the event of a disaster so as to ensure minimum impact on the business. 2. Insurance. Adequate insurance must be able to replace information systems assets and to cover the extra costs associated with restoring normal operations. G. Operations management controls. 1. Computer operations ensures proper functioning of H, W and S, W on day-to-day basis. 2. Network operations ensures proper functioning of network devices, communication channels, etc. 3. Data preparation and entry keyboard environment and facilities should be designed to promote speed and efficiency. 4. File library management of org. Data stored in machine-readable storage media like CD, DVD, pen drive and hard disk. 5. Help desk. Technical support assist end-user in deploying and using H, W and S, W and resolving issues. 6. Documentation and program library ensures documentation of security policy, BCP, DRP. System development related documents. 7. Management of outsourced operations responsible for carrying out day-to-day monitoring of outsourced contracts. 2. Application control framework. Objective. App controls ensures data remains complete, accurate and valid through input, update, and storage. It involves ensuring that individual application systems safeguard assets, maintain data integrity and achieve objectives effectively and efficiently. An audit trail records all the material events that occur within the system to analyze and search for error or irregularities. AT controls ensures that a chronological record of all events occurs in a system is maintained. This record is needed to answer queries, fulfill statutory requirements, detect the consequences of error, and allow system monitoring and tuning. Provides preventive and detective control to help achieve security objectives. Example: app logs contain details. W. R. T. Who initiated a transaction, who authorized it, date, time, etc. Accounting at maintains a record of events within the system. Operations at maintains a record of attempted or actual resource consumption associated with each event in a system. Types are boundary controls, access control mechanisms that links the authentic users to the authorized resources. Involves identification and authentication of users by S, W and authorization, i.e., privilege management. I. Cryptographic controls, designed to protect the privacy of data and prevent unauthorized modification of data. Involves conversion of clear text into a ciphertext for storage and transmission over networks by sender. Receiver decrypts this cipher code using auth key. Strength of cryptography depends on time and cost to decipher the ciphertext by cryptoanalyst. 3. Techniques of cryptography are a transposition, permute the order of characters within a set of data. B. Substitution, replace text with a key text. C. Product cipher, combination of transposition and substitution. E. Access controls. These controls restrict the use of computer system resources to authorized users and limit the actions authorized users can take with these resources. The access control mechanism involves 3 steps. A. User identification, done by user itself by providing his, her unique user ID allotted to him, her or account number. B. Authentication mechanism is used for proving the identity with the help of a password or biometric identification including thumb impression, eye retina, etc. C. Authorization, the set of actions allowed to a user once authentication is done successfully. For example, read, write, print, etc. Permissions allowed to an individual user. E. Personal identification numbers, PIN. It is a form of remembered information used to authenticate users, like verification of customers in electronic fund transfer systems. PIN is like a password assigned to a user by an institution, a random number stored in its database independent to a user identification details. Several phases of the life cycle of PINs include the steps that are a generation of the PIN, b. issuance and delivery of PIN to users, c. validation of the PIN upon entry at the terminal device, d. transmission of the PIN across communication lines, e. processing of the PIN, f. storage of the PIN, g. change of the PIN, h. replacement of the PIN, and I. termination of the PIN. IV. digital signatures is used as an analog signature for e-documents. Digital signatures are not constant like analog signatures. They vary across messages and cannot be forged. Vi. plastic cards, while PIN and digital signatures are used for authentication purposes. Plastic cards are used primarily for identification purpose. This includes the phases, namely, application for a card, preparation of the card, issue of the card, use of the card, and card return or card termination. VII. Audit trail. Controls accounting. Audit trail includes details like authentication information supplied, resources requested, provided or denied, terminal identifier and start, Finish time action. Privileges allowed. Denied operations audit trail includes details like resource usage from log on to log out time and log of resource consumption. B. Input controls. Applied to ensure that data input in system is authorized, accurate, correct and complete. Data code controls. These controls are aimed at reducing the error during data feeding or transcription error in entry made by human or OCR. Types: black small square addition error, extra digit added, black small square truncation error, digit is removed, black small square substitution error, replacement T of a digit with another O transposition error, change in position of 2 digits while entry is made. Types: black small square. Single 2 adjacent digits are reversed. Black small square multiple non-adjacent digits are changed. Batch controls. Process of grouping together transactions that have some relationship with each other. O financial totals. Grand total is calculated for each field containing G monetary amount. O hash totals. Grand total is calculate D for any code on a doc in the batch. E.g. source doc serial no. O doc counts. Grand total of no of docs record in the batch. Validation of data input controls. Intended to detect errors in transaction data before data is processed. O field check. Examines characters of data in the field. Includes black small square limit check against predefined limit black small square. Picture check against invalid characters black small square valid check codes against predetermined transactions. Codes, tables O record check. Includes black small square reasonableness check, i.e., whether value in field is reasonable or not. Black small square valid sign to determine which sign is valid for a numeric field. E.g., weight can't be in cm black small square sequence check to follow a required order matching with a logical seq. O file check. Includes black small square version usage. Always use latest version black small square data file security. For access to authorized D users only. Black small square file updating and maintenance done by auth users. Only audit trail controls. Accounting audit trail includes details like origin, contents, and timing of transaction entered into application system details regarding the identity of the person, organization, who was the source of the data and who entered the data into the system. Time and date when the data was captured, the identifier of the physical device used to enter the data into the system, the standing data to be updated by the transaction, the number of the physical or logical batch to which the transaction belongs. Operations audit trail includes details like time to enter data and the terminal number of read errors made by an optical scanning device, number of keying errors identified during verification, time taken to invoke an instruction using different input devices like light pen or mouse. C. Processing controls. Responsible for computing, classifying and summarizing data. Processor controls. To reduce errors and irregularities in processing. A. Error detection and correction. Processor may malfunction due to design defect, damage, etc. Failure can be transient, temporary, intermittent, periodic, or permanent. Transient or intermittent errors, restart the device. Permanent errors, halt the processor and report. B. Timing control. CPU should run a program for specified time only. Once time is completed, another program should run, else there will be infinite loop and it will consume CPU. C. Component replication. In some cases, processor failure can result in heavy losses. Hence, redundant processor should be kept. Real memory controls seeks to detect and correct error of real memory, RAM, and prevent unauthorized access. Virtual memory controls used when RAM is insufficient to execute a program. This control is required to map virtual memory address with real memory address. Application software controls. These perform validation checks to identify errors during processing of data, required to ensure both the completeness and the accuracy of data being processed, generally enforced through DBMS. Audit trail controls. Accounting audit trail includes data items like to trace and replicate the processing performed on an input data item, intermediate results and output data values, to check for existence of any data flow diagrams or flowcharts that describe data flow in transaction. Whether such diagrams or flowcharts correctly identify the flow of data and who made them. Operations audit trail includes details like comprehensive log on hardware consumption, CPU time used, secondary storage space used, and communication facilities used, and comprehensive log on software consumption. D. Output controls. Inference controls used to prevent compromise of statistical databases from which users can obtain only aggregate statistics rather than the values of individual data items. Batch output production and distribution controls. Batch output in the form of tables, graphs or images is produced at some operations facility and distributed to users. Includes several controls like a report program execution controls to ensure that only authorized users are permitted to execute batch report programs, and these events are logged and monitored. B. Spooling file controls so that the users can continue working while a queue of documents waiting to be printed on a particular printer. C. Printing controls to ensure that output is made on the correct printer, and unauthorized disclosure of printed information does not take place. D. Report collection controls to ensure that report is collected immediately and secured to avoid unauthorized disclosure and data leakage. E. User client service review controls to ensure user should obtain higher quality output and detection of errors or irregularities in output. F. Report distribution controls ensuring that the time gap between generation and distribution of reports is reduced, and a log is maintained for reports that were generated and to whom these were distributed. G. User output controls to be in place to ensure that users review output on a timely basis. H. Storage controls to ensure proper perseverance of output in an ideal environment, secured storage of output. I. Retention and destruction controls in terms of deciding the time duration for which the output shall be retained and then destroyed when not required. Batch report design controls should comply with the control procedures laid down for them during the output process. Online output production and distribution controls deals with the controls to be considered at various phases, like establishing the output at the source, distributing, communicating, receiving, viewing, retaining and destructing the output. A. Source controls ensure that output which can be generated or accessed online is authorized, complete and timely. B. Distribution controls to prevent unauthorized copying of online output when it was distributed to a terminal. C. Communication controls to reduce exposures from attacks during transmission. D. Receipt controls to evaluate whether the output should be accepted or rejected. E. Review controls to ensure timely action of intended recipients on the output. F. Disposition controls to educate employees the actions that can be taken on the online output they receive. And G. Retention controls to evaluate for how long the output is to be retained. And H. Deletion controls to delete the output once expired. Audit trail controls. Accounting audit trail includes data items like what output was assimilated for presentation to the users, what output was then presented to the users who received the output, when the output was received, and what actions were subsequently taken with output. Operations audit trail includes details like record of resources consumed by components in the output system, response times and display rates for output. E. Database controls applied to maintain integrity of database, to prevent integrity violations when multiple programs have concurrent access to data, and ways in which data privacy can be preserved within the system. I. Access controls seeks to prevent unauthorized access to and use of the data. A security policy has to be specified, followed by choosing an access control mechanism that will enforce the policy chosen. E. Integrity controls. These are required to ensure ICAI of the database. E. Application software controls. When App SW acts as an interface to interact between the user and the database, DBMS depends on App SW to update the database correctly. This is achieved through a update controls that ensure that changes to the database reflect changes to the real-world entities, and B. Report controls that identify errors or irregularities that may have occurred when the database has been updated. IV. Concurrency controls required to address the situation that arises either due to simultaneous access to the same database or due to deadlock. V. Cryptographic controls already discussed under boundary controls. Vi. File handling controls used to prevent accidental destruction of data contained on a storage medium. These are exercised by H, W, S, W, and the users who load, unload storage media. VII. Audit trail controls. Accounting audit trail includes details like whether an app properly accepts, processes, and stores information, and unique timestamp to all transactions. Before images and after images of the data item on which a transaction is applied to the audit trail. Operations audit trail includes details like resource consumption events that affects the database definition or the database. F. Communication controls applied to ensure that the data transmitted over network is accurate, complete and authentic. I. Physical component controls. Physical components shall have characteristics that make them reliable and incorporate features and controls that mitigate the possible effects of exposures. Major physical components that affect the reliability of communication system are transmission media, communication lines, modem, port protection devices, multiplexers, and concentrators etc. E. Line error controls. While transmission of data through transmission line, there can be data loss due to noise distortion called line error. These errors must be detected and corrected. E. Flow controls applied when there is difference in speed at which two nodes in a network can send, receive or process data, resulting in loss of data. Flow controls will be used therefore to prevent the mainframe flooding the microcomputer and as a result, data being lost. IV. Link controls in wide area network, WAN. It refers to combination of line error controls and flow controls. V. Topological controls. A communication network topology specifies the location of nodes within a network, the ways in which these nodes will be linked, and the data transmission capabilities of the links between the nodes. VI. Channel access controls. Two different nodes in a network can compete to user communication. Channel. Where possibility of contention of channel exists, some type of channel access control, like a polling method, defining an order in which a node can gain access to a channel capacity, or B. Contention method. Nodes in network must compete with each other to gain access to a channel. Must be used. VII. Controls over subversive threats. Firstly, physical barriers are needed to be established to access the data. Secondly, in case the intruder has somehow gained access to the data needs to be rendered useless when access occurs. VII. Internetworking controls. Different internetworking devices like bridge, router, gateways are used to establish connectivity between homogeneous or heterogeneous networks. Therefore, several control functions in terms of access control mechanisms, security and reliability of the networks are required to be established. X. Audit trail controls. Accounting audit trail includes collection of the data like unique identifier of the source, destination and each node that transmits the message. Unique identifier of the person or process authorizing dispatch of the message, time and date at which the message was dispatched and received. Message sequence number. Operations audit trail includes details like number of messages that have been transmitted at each link and each node, number of errors occurring on each link or at each node, number of retransmissions that have occurred across each link, log of errors to identify locations and patterns of errors, log of system restarts. Big data, massive large data sets that conventional database tools do not have processing power to analyze them. E.g., Google handle billions of searches every day. Industries that use it analytics include e-commerce, Amazon, retail business, Walmart, healthcare industry, hospitality industry, etc. Benefits of big data processing are improved customer services, as it helps in reading and evaluating customer feedback. B. Better operational efficiency. Integration of big data technologies and data warehouse helps an org to offload infrequently accessed data, this improving efficiency. C. Better decision making. By using outside intelligence, e.g. access to social data from Facebook, Twitter, etc., helps org to fine-tune their business strategy. Also helps in early identification of risk to the products, services. If any data warehouse is a large collection of business data used for storage and analysis to help an organization make decisions. Directly analyzing the data that is needed for day-to-day operations is not a good idea as it creates interference in normal functioning of organization. The process of extracting data from operational databases and bringing it into the data warehouse is commonly called ETL, which stands for extraction, transformation, and loading. A. First stage. The data is extracted from one or more of the organization's databases. B. Second stage. The data so extracted is placed in a temporary area called staging area where it is transformed like cleansing, sorting, filtering etc. of the data as per the information requirements. C. Final stage. Loading of the data so transformed into a data warehouse which itself is another database for storage and analysis. Features, i.e. data warehouse should meet following criteria. A. Uses non-operational data, i.e. a copy of data from the active databases. B. Data is time variant, i.e. when data is loaded in data warehouse, it receives timestamp which allows org to compare over a period of time. C. Data is standardized in terms of rules and format like date, units of measurements, etc. 2. School of thoughts. Approach, bottom-up approach. Step I. Create small data warehouses known as data marts to solve specific problems. Step 2. Combine them to form large data warehouse. Top-down approach. Step I. Create enterprise-wide data warehouse. Step 2. As specific needs are identified, create smaller data marts from data warehouse. Benefits of database warehouse. A. Better understanding of data. B. Determine inconsistent data as it provides centralized view of all collected data. C. Generate one version of truth, viz. number of employees, sales, etc. D. Create historical record of data which allows an organization to analyze trends. E. Data warehouse can be used along with business intelligence tools for new information and analysis. Data mining, process of analyzing large data to find previously unknown trends and pattern to make decision. This is accomplished through automated means against extremely large data sets such as data warehouse. Examples of data mining tools: MS Excel, Oracle data mining. Rapid miner. Steps involved in the data mining process. 1. Data integration. Data is collected and integrated from all the different sources which could be flat files, relational database, data warehouse or web, etc. 2. Data selection. All the collected data may not be required for data mining. So, we select only those data which we think is useful for data mining. 3. Data cleaning. The data that is collected may contain errors, missing values, or inconsistent data. It needs to be cleaned to remove all such inconsistencies. 4. Data transformation. The cleaned data needs to be transformed into an appropriate form for mining using different techniques like smoothing, aggregation, normalization, etc. 5. Data mining. Various data mining tools are applied on the data to discover the interesting hidden patterns. 6. Pattern evaluation and knowledge presentation. Involves visualization, transformation, removing redundant patterns, etc. from the patterns generated from data mining. 7. Decisions. Use of discovered knowledge. This step helps user to make use of the knowledge acquired to take better informed decisions. Differences. B. W database. Data warehouse and data mining database. This stores real-time information. Example: telecommunication sector. The database stores information related to monthly billing details, call records, minimum balance, etc. Its function is to record data warehouse. This stores both historic and transactional data. Example: telecommunication sector. Information in a data warehouse will be used for product promotions, decisions relating to sales, cashback offers, etc. Its function is to report and analyze data mining. This analyzes data to find previously unknown trends. Example: telecommunication sector. Information will be analyzed by data mining techniques to find out call duration with respect to particular age group from the entire data available. Its function is to extract useful data. Information systems auditing. BI is auditor, process of attesting, assuring, confirming objective of external auditor that focuses on safeguarding of assets and integrity of data, and internal auditor that focuses on effectiveness and efficiency. Objectives of IS audit: 1. Asset safeguarding. IS asset, i.e. H, W, S, W, data, info etc. must be protected by using internal control from unauthorized access. 2. Data integrity. Fundamental attribute, quality, of auditing. It should be maintained at all time, and data should not be accessible to unauthorized users. 3. System effectiveness. Involves evaluating whether IS meets requirements of business and users in decision making or not. 4. System efficiency. To optimize use of various IS resources to complete task with minimum consumption of resources. Reasons. Need for IS audit: factors which influence organization, MGT, W, R, T, implementation of controls and audit of computers are 1. Value of computer H, W, S, W and personnel. These IS resources are valuable and important and must be safeguarded. 2. Maintenance of privacy. An organization collects a lot of data which are private. Regarding individuals, any leakage of private personnel data is against interest of company and must be protected. 3. Controlled evolution of computer use. Use of technology and reliability of computer system can't be guaranteed. Hence it must be audited. 4. Cost of data loss. Data is very critical resource of an organization. Data loss can cause severe damage to organization and hence it must be protected. 5. Cost of incorrect decision. Management takes decisions based on information produced by IS. In case of incorrect info, management can take incorrect decision, which affects the organization adversely. 6. Cost of computer abuse. Unauthorized access to computer system may cause huge damage. It may also result in introduction of virus, malware, hacking, theft of data etc. 7. Cost of computer error. Error may occur while performing a task, which may incur huge cost for ORGN. IS continuous audit. Real-time production of information. Real-time recording. Real-time auditing. Continuous assurance about quality of data. Continuous audit reduces time gap between occurrence of client's event and auditor's assurance service. There are 2 bases for collecting audit evidence: a embedded module, audit S, W, in system to collect, process and print audit evidence. B. Special audit records used to store audit evidence. Collected. Types of continuous audit tools. 1. Snapshots. O helps in tracing a transaction as it flows in app system. O built into the system at points where material processing takes place. O takes image of flow of transactions as it moves through the app. O these images are utilized to assess authenticity, completeness and accuracy of process being carried out by system. A. Locate. The snapshot point based on materiality. B. Determine when will snapshot be captured. C. Reporting. System is designed and implemented to present data in meaningful manner. 2. Integrated test. Facility. OITF involves creation of dummy entity, test data in app system. O this test data is incorporated in normal data used as input in app system as a means to verify processing. Authenticity. completeness and accuracy. O auditor must decide a method to be used to enter test data in system. B. Method for removing effect of ITF transaction. 3. System control audit. Review file. O involves embedding audit SW module within an app system to provide continuous monitoring of systems transactions. O info collected is written on SCARF master file. O similar to snapshot technique with data collection capabilities. 4. Continuous and intermittent simulation. O variation of SCARF. O used as trap exception whenever app system uses DBMS. O procedure black small square. DBMS passes all transactions to SYS, which determines whether it wants to examine it further. Black small square. SYS simulates the app system process. Black small square result of selected transactions processed by SYS is compared with result produced by app SW to determine whether both are same or not. Black small square in case of any diff. Exceptions are identified by SYS and written to exception file. O advantage. No modification in app system but provides online audit capability. 5. Audit hook. O audit routines. That flags, highlights suspicious transactions as soon as they occur on a real-time basis. O auditors can be informed of questionable transactions as soon as they occur. This approach of real-time notification displays a message on auditor's terminal. Advantages of continuous audit techniques. 1. Timely, comprehensive and detailed auditing. Evidence would be available timelier and in a comprehensive manner. Entire processing can be evaluated and analyzed rather than examining inputs and outputs only. 2. Surprise test capability. As evidences are collected from the system itself by using continuous audit techniques, auditors can gather evidence without knowledge of system staff and application system users. This brings in the surprise test advantages. 3. Information to system staff on meeting of objectives. Continuous audit technique provides information to system staff regarding the test vehicle to be used in evaluating whether an application system meets the objectives of asset safeguarding, data integrity, effectiveness, and efficiency. 4. Training for new users. Using the integrated test facilities, ITF, new users can submit data to the application system, and obtain feedback on any mistakes they make via the system's error reports. Audit trail objectives of audit trail. 1. Detecting unauthorized access in real time or after the event. Helps protect the system from outsiders who are attempting to breach control. 2. Reconstructing events. Used to reconstruct the steps that led to events such as system failures, security violations by individuals, or app processing errors. Such knowledge can be used to assign responsibility and to avoid similar situations in the future. 3. Personal accountability. Audit trail is used to monitor user activity at lowest level of detail. Preventive capability, i.e. acts as deterrent for potential violators if they know that their actions are not recorded in an audit log. Implementing audit trail. Generating audit trails info in audit trail is useful for accountants in measuring damage or loss due to app errors, abuse of authority, etc. It helps in assessing whether controls in place are adequate or not and need for additional control. Audit logs can generate data in overwhelming detail. Important information can easily get lost among the superfluous detail of daily operation. Thus, poorly designed logs can be useless. Audit of various IS controls. Role of IS auditor. A. To determine whether objectives of controls are met or not. B. Assess effectiveness of controls. Audit of controls. A auditor shall conduct risk assessment. Higher risk, more control. B. He shall conduct review of controls, i.e., whether controls are implemented or not and whether working effectively or not. C. Shall also check whether controls are monitored by qualified personnel or not. Segregation of duties. It advocates that privilege, access rights should be given on need to do and need to know basis. Ensures that single individual do not passes excess privilege that could result in unauthorized activity like fraud or manipulation of data security. For example, the person approving the purchase orders should not be allowed to make payment and pass entries in the books. At the same time, both preventive and detective control should be placed to manage SOD control. Examples of SOD controls: transaction authorization. IS requires 2 or more persons to approve certain transactions, split custody of high-value assets, password to an encryption key that protects sensitive data can be split in 2 halves, one half assigned to 2 persons, and the other half assigned to 2 persons, so that no single individual knows the entire password. 2 keys for sensitive locker. Periodic review of user rights. Internal audit personnel can periodically review user access rights to identify whether any segregation of duties issues exist. Workflow. Applications that are workflow enabled can use a second or third level of approval before certain high value or high sensitivity activities can take place. E.g., workflow application that is used to set up user accounts can include extra MGT approval steps in requests for administrative privileges. When SOD issues, conflicts B.W. access rights of individuals are encountered, management needs to mitigate the matter. How? Reduce access privilege of individual user so that conflict no longer exists. Introduces new mitigation control if management determines that the person need to retain privileges which are viewed as conflict. New preventive and detective control needs to be implemented, like increased logging of records, reconciliations of datasets, etc.